Hello, good morning.
Morning, sir.
Thank you. Okay, good morning once again. I already presented my screen, so I hope you can view it. Okay, could you please confirm, Rona May Fuentes? Can you
Yes,
view my
sir.
screen?
Yes, sir.
Thank you. So the topic for this morning, that's relative equilibrium. What do we mean by relative equilibrium? Uh, we will be dealing here with fluid that is moving with the container. So the container and the fluid is not in the state of equilibrium if the tank is accelerating either to the right, to the left, up or down. But the liquid inside the tank is in the state of equilibrium relative to the tank. That's why we call it relative equilibrium. Now let's consider a situation where there is a tank. So this is the side view, and this is the appearance of the tank. So the liquid surface is horizontal when the tank is not moving, or if the tank is moving, there is no acceleration involved. Okay, so there is no acceleration, then the water surface or the liquid surface is horizontal. But then if you are going to accelerate the tank to the right side, the liquid surface inside the tank will assume an inclined position. So there is an angle theta, and this position is fixed relative to the tank, meaning the liquid inside will not keep on moving. No? So it will stay in this position. That's why we call it relative equilibrium. For the analysis, what we will do is consider a liquid particle on the surface. So if we consider a liquid particle on the surface, this particle, as an example, we isolate it here. We consider all the forces acting on this particular element. The forces are the weight of the element. So we have W, and the reaction offered. Now, the reaction offered by the neighboring particle. So take note, there are so many particles here, and we are just considering a differential element. Oh, that's what we call as particle. Now on this side, the forces acting would be the same as the forces acting on this side. Okay, so we have a force acting at the bottom, and that is the reaction offered by the other liquid particles. Obviously, the two forces are not in the state of equilibrium. Two forces cannot make a particle equilibrium if the forces are not collinear. Okay, so we will put the particle in a state called dynamic. So this is now dynamic equilibrium. So how to place an accelerating body into a dynamic equilibrium state? We just add a reverse. This is actually an imaginary force. We call it as the reverse effective force. I repeat, to make the particle in the state of equilibrium, we call it dynamic equilibrium, we apply a force equal to mass times acceleration applied opposite to the direction of the acceleration. So the acceleration is to the right, then the reverse effective force is applied to the left. So maybe it would be representative to make this dotted line now because this is an imaginary force. But the role of this force is to make the system equilibrium. So if this is equilibrium already, then we can construct what we call a force triangle, starting with the weight, which is vertically down, then the reverse effective force, a force going left, and then the reaction R will close the polygon. If the polygon is closed, it means to say that the forces involved are in the state of equilibrium. Normally, we will be interested at the angle of inclination of the liquid surface, theta. So how to solve for theta? You look at this force triangle, you can involve a side opposite to the angle and another side adjacent to the angle. And that function is tangent. No? The tangent of theta is mass times acceleration all over mass times g. You can remove the mass, and therefore the tangent of the angle of inclination equals the ratio of acceleration A divided by the acceleration due to gravity. I hope that's not difficult to understand. Again, if the tank is accelerated horizontally to the right or to the left, then the angle of inclination formed by the liquid surface equals the tangent of that, the tangent theta equals A over G. Any question or clarification? Let me check on Alexi, Nicole.
No, sir.
Okay, thank you. Next is we consider a tank which is accelerating upward, no, vertically. So vertically upward. So this is the situation, the liquid particle or the liquid surface horizontal. When you accelerate the tank vertically up, the liquid surface remains horizontal. But we will now analyze a prism. This time we consider a prism of fluid or liquid, the length of which h and the top cross-sectional area is indicated as A. The bottom cross-sectional area is B. But because we are considering this as a prism, meaning the cross-sectional area is constant all throughout. That's prism, the cross-sectional area constant all throughout. If we analyze the prism, the forces acting are the following, assuming there is no acceleration involved. There is no acceleration involved since the top portion is already below the liquid surface. So there is pressure due to the fluid. If you multiply that pressure by the area, what you will get is a force. So force A is simply equal to pressure A, multiply it by the differential area. which is the cross-sectional area of the prism. The weight of the prism, the weight is calculated as gamma, gamma times volume, and the volume is height times cross-sectional area. This is the weight of the prism. It will be balanced by the force going up. Now, balanced because the three forces are in the state of equilibrium if the tank is not accelerating. Take note of that. So, the force at the bottom would be the pressure at the bottom, multiply it by the differential area, where the pressure at the bottom is calculated as gamma h, gamma h plus the pressure at the top. And therefore, PB minus PA equals gamma h. Delta P equals gamma h. Hello, no? So you can take note, you can remove the differential area here. That one, this one, and this one. So the difference in pressure would be simply gamma h if the tank is not moving vertically. If the tank is accelerating vertically, again, we have to situate the object in dynamic equilibrium by adding an imaginary reverse effective force. So this is now the free body diagram, and look, the direction of the reverse effective force is always opposite to the direction of motion. I hope that's clear. Huh? Okay, so the reverse effective force here is opposite to the direction of the acceleration. And again, by adding an imaginary reverse effective force, you are putting the system into a state called dynamic equilibrium. Because this is dynamic equilibrium, meaning you can sum up forces and equate it to zero. Summation of forces is zero. And this is correct only if the system is equilibrium. Dynamic, in this case, dynamic equilibrium. The forces involved going down, PA and W. So PA and W. And reverse effective force also going down. Force up, FB. So how do we calculate for FA? FA is now the pressure at A times the differential area. And this pressure is not the same as the, I just call there N, just to differentiate it from the PA. W, the weight of the liquid, and REF, that's the reverse effective force, is mass times acceleration. Then this is the pressure at the bottom and multiply the same area, dA. So again, you can just combine the W and MA. This time you cannot cancel out the dA because there is no dA for here and here, no? But we can combine this and that. So we have now PB minus PA. We factor out the common term, dA. Then we factor out W. We get W 1 plus A over G. Okay, so W can now be expressed as unit weight times volume, where volume is its differential area. So this time we can remove the dA, and you notice that the difference in pressure when the tank is accelerating up is equal to the original pressure and plus the factor A over G times the original okay, the original value. Meaning to say, if the tank is accelerating upward, the difference in pressure will increase, no? And the factor is 1 plus A over G. If the tank is accelerating downward, I will not present the derivation anymore. Tank is accelerating downward, then you just change the plus to minus, meaning the difference in pressure will decrease if the tank accelerates downward. Okay, I hope that's not difficult to understand. Let's consider now an example. The tank shown, this is the side view. So the tank is 4 meters length or long, 3 meters high, but it is not full of water. So the water is only up to 2.5 meters, no, from the bottom. So the depth of the water is only 2.5 meters. This tank is uniformly accelerated to the right. That means the acceleration is constant at 16 meters per second. We are interested of the following. What's the maximum pressure intensity? Maximum pressure intensity. Then the hydrostatic force acting on the left wall. The left wall meaning sa tank. Inisya mo ni ang right wall considering this view. Okay. The last requirement is the force acting against the cover. So this is a cover. And take note, there is a small opening at the right end, this one here. So the small opening is simply to indicate that there is no air pressure inside the tank. Meaning this air is exposed to the atmosphere. So the pressure at the top of the liquid is 0 gauge. Is 0 gauge. So what will happen if the tank is accelerated to the right? The liquid surface will be inclined, and probably it will incline in this manner. Now, we do not know yet. That's why we have to check whether this is the assumed position of the new liquid surface. Somewhere here, the liquid cannot go out because there is a cover. Okay, so if you are going to expand this, this will be the imaginary liquid surface. So that should be the position that the liquid surface will take, assuming that there is enough wall at the rear side. If there is enough wall that can prevent the liquid from spilling out. Well, geometrically, if we apply geometry here, light and geometry, I believe you will agree with me that the volume in a space, ng space, would be equal to kining space. Ini siya nga part, ba? Kay wala may water nga nakascape, right? So, wala water nga nakascape sa container, meaning the volume of the water original would be the same as the final volume, meaning the empty portion of the tank would be the same as the empty portion original. Okay, how do we obtain the slope of the water surface? I believe we still remember the formula. Tangent theta A over G. Okay, so if we get the relationship between X and Y, and we can just do ratio and proportion, no? The tangent of theta would be equal to Y over X. But the tangent of theta is also A over G. This is the acceleration, and this is the acceleration due to gravity. Meaning, the Y in relation to X is 1.631x. We call it equation 1. Next is the volume of air remains the same. The volume of air. If you consider the original, before the tank is accelerated, the volume empty, meaning the volume of air, is 4 times the thickness, multiply it by the width. Okay, 4 is the length. Then multiply it by this one, and multiply it by the width. So the tank has a shape like this, na? Ano na ang tanke. And this is the 2 meters. That's the dimension perpendicular to the screen. Okay, so if we apply the relationship, the volume of air original, the same as the volume of air final, or the volume of air final would be equal to the cross-sectional area, which is now the triangle, this one, yeah, multiply na sa imo sa length. So that would be murag wedge na siya, na shape, no? So this is the volume that we are talking about. So cross-sectional area, triangle, 1/2 base times height, multiply it by the thickness, 2 meters. Meaning, the value xy, because you can just remove it, the value xy equals 4. This is equation 2. And then we combine equation 1 and 2, x times y, or y is 1.631x. Therefore, the value of x is 1.556. 1.556. And the value of y is 2.554. That's the value of y. Since the total height is 3, and the value of y is only 2.554, so meaning there is still a distance from the bottom. And that distance would be 3 minus 2.54. I hope you are following. So the pressure intensity, if we consider this portion here, this is the point of maximum pressure. Okay, this is the point of zero pressure. And this is the line indicating zero pressure. So, the maximum pressure intensity is calculated as gamma, multiply it by the depth of the liquid, either real or imaginary, and that it should be from here up to here, meaning it is 3 plus z. 3 plus z. And how do we calculate for the z? We do ratio and proportion. Okay, ratio and proportion would be Kinesia, which is 4 minus the value of x. Okay, I repeat, this side would be equal to 4 minus the value of x. Okay, I hope klaro na siya, no? Then, z over this one would be equal to y over x. Z over b equals y over x equals y is 1.631x and divided by x. So the Z equals B times 1.631, where the value of B is 1.446, meaning the Z value is 2.358. You add to it 3 to obtain the total height H. Therefore, the pressure is now 9.81. Multiply it by H, or equivalent to 52.562. I would like to entertain questions if there are questions or clarifications. Okay, there's none. So that's the answer to question number 1, no? Maximum pressure intensity in the tank. So that will happen at this point of the tank. So this is the critical point of the tank. Next is we will calculate for, it's not here already. So the next is the hydrostatic force acting on the left wall. Left wall. The left wall, as already mentioned, refers to, in relation to the movement, the rear side, because movement of the tank is that way. So the left wall or the rear side would be the same. We are now interested of the hydrostatic force acting on the left side. Okay? So how do we do that? How do we solve for it? Okay, wala man diri sa atong slides. So can we probably get our calculator and let's solve for it? Okay. So question now is, what is the force acting carrying a wall? Now the wall, ingon inira ang iyang dimension, no? 2 meters na siya, 3 meters ni. But the liquid pressure na muak niya would be like this. Ana. Mani ang liquid pressure. Okay? So maybe I'll give you time to solve for it. And yeah, I will call somebody to share his or her answer. So the 2 minutes starts now. And after 2 minutes, I will just call you at random. Please start. Use your calculator. Now, those who got the answer already, you can just type it sa chat box. Okay, so I believe we have the answer already. So nobody is typing on the chat box. So let me just call you at random. Patrick, Jerome. Hello, Patrick. Hello, Patrick. Are you there? Not there. How about si Farga, Albern? Albern.
Wala ko answer, sir.
Uy, may answer. Ano mo may answer? Ito ni Bianca. Bianca?
Wala po ko kahuman sir sa pag-solve. Sorry sir.
Okay. Nari ni Marfil. Marfil?
Ito ba, sir? 315 kilonewtons?
Okay, so I'll take note of your answer, no? Marfil. Let's spell ito, 300. Pareho lang kung type sa chat box.
315.37.
Chat box sa Marfil. Okay, 315.37. Kita taglaing answer. Si Edgar Abelia.
Still
Abelia,
processing kasi wala pa kukuha sa answer, sir.
okay, Abelia, no answer. Juano, John Lloyd. Juano,
I also do not have an answer, sir.
no answer. Fuentes, Rona. Fuentes.
Ako nga pa, sir.
Could you please type it sa chat box para dili ma-feedback? (161.3). Okay, another one. How about si Lindsay, Ambayan? Ambayan.
Yes. Sir, I'm not sure, sir, pero 420.4958.
You will type sa chat box, Lindsay. Chat box, please, Lindsay. Or 20.5. Si Daniel Burgos, sorry, Daniel Burgos. Hello. Not there. How about Misa, Rodolfo? Misa, what's your answer? Misa,
Nag-calculate pa ako, sir.
Misa, calculate pa. Why answer? Gomez, Roy. Gomez. Gomez is 29.37. Okay, so at least we have 4 answers here. 315, 161, 420, 29.37. Itong analyzon siya, no? Expect ko nga nakakuha na tas mga answers, questions like ining particular problem. Okay, so we are interested of the force acting during a side. Parehara man na calculation sa submerged surfaces. Pero ang liquid surface di adire because this is the level of zero pressure. No? Mamani ang imaginary liquid surface. So ang pressure distribution would be like this. Side view, no? That's the pressure distribution. Nakay pressure dire, nasa kay pressure dire. Okay, so kung there are several ways of doing this. No? Unang-una is kini mo i-consider nimo nga submerged surface. So sa submerged surface, kuha ra ka og pressure develop at the centroid. And how to calculate for that? Gamma h bar, where the value h bar is the distance kandiha. So pila man eh? This is equal to 1/2 of 3, 1.5 ne? Ini sub 1.5. Kini siya z value, which is 2.358. 2.358. So question, unsa may pressure nga ma-develop diri sa centroid sa submerged surface? 9.81 multiplian of gamma h, where gamma h is 1.5 plus 2.358. Mo ning pressure, multiply nimo sa area, sa may area nga nakontak sa water, that's height times the thickness. So mo ni siya ang force na ma-develop. So palihog kong tanaw kung igo ba sa atong mga answers. Okay? So, any questions so far?
Sir, excuse me, sir.
Yes.
Pwede ko magpa-clarify sa pagkuha sa B, sir, kay 4 minus x, sir, ba niya? Ang gigamit kay ang 2554, dili ang katong 1.566, sir?
Ang pag-calculate sa
B.
B? Okay, ang pag-calculate sa B,
kay 4 minus x, manggod siya, sir, niya. Ang gigamit kay ang 2.554, I think.
okay. So, ang question dire is, ang pag-calculate sa B, kini siya, no? Na it should be 4 minus kining x.
Sir.
Okay. So, ang nagamit nato is kini. Ang correct value is 1.556. Okay, so we have to correct that one. Thank you for that clarification. Okay, so the value of B should be 4 minus, no? 4 minus 1 point, kinesia, 1.566. Pero ang nagamit diri is 2.554. So atong i-check, no, using another method. Kini obviously sayop na siya because X should be deducted to obtain the B. So ang B nga nakuha diri is 1.446, which is obviously not correct. Okay, so if that's the case, I guess we need to make the correction. Kaya ito ni siya i-correct. The value of B will now become, this should be 1.554. 1.566. And therefore, this will become, we use our calculator, that should be 2.434. You get the same result?
Yes, sir.
Okay, so Z over B, this one now will become, this is okay because it should be 1.6, but this one now will become 2.434. So this one now is not correct, right? The correct value should be 1.631, then times 2.434. And the answer is
97, sir. 3.97.
Okay, we round it off. So this one will become 3.97, or the total now will become 6.97. So the value H will now become 6.97. So you just change this to 6.97. And this one will also change. Times 9.81. So that gives us 68.4 or 37. Okay. So the correct value of Z, if we are going to correct this, it should be 3.97. So the pressure at the centroid of the submerged surface will now become gamma, multiply it by h bar, or it's equal to 9.81, multiply it by h bar, where the value h bar would be 1.5 plus 3.97, or it should be 9.81 times 1.5 plus 3.97. The answer is 53.66. And this is in kilopascals. So the force developed now equal to 53.66. Multiply it by the area becomes 3 times 2. So multiply that by 6. The answer is now 321.97 or 96. Okay, are you following? So this is the corrected value. It's 321. Yeah, so 321.96. That's the value after correcting it. Yan na. The next question is, so use the corrected value now. The next question is, what is the force acting against the cover of the tank? Okay, please do the calculation. What is the force acting against the cover? Where this time the value of B, this one here, that would be the value B this time is 2.434. So I'll give you another 2 minutes to get the answer. So the 2 minutes starts now. Then after 2 minutes, I will call you at random. Okay, time is up. So let me now check your answers. If your name is called, you can type your answers at chat box because I'm also recording it. Jmar, Philip, Adlaw. Adlaw just left the meeting. Adlaw, 0. How about Benuisa? Petea? Benuisa? Benuisa? Okay, 189.588. Next is Auman, Jeremiah, Auman. Auman is also 189.57. Palita, Dionis Palita. Palita, type please, chat box. Okay, 249. 0.245. Branzuela. Branzuela. Type please your answers at chat box. Branzuela. 116.24. Okay, one more. Mundo Nido. Lester. Lester, what's your answer? 143. Mundo Nido. Okay, now if we are interested calculating the force acting on the cover, just like in submerged surfaces, the force acting on this part would just be equal to the weight of the imaginary liquid. And because it is imaginary liquid, then the force will be acting upward instead of downward. So how do we calculate for the weight? The weight is just equal to the volume of the prism in this case, because the thickness is 2 meters. So we will be interested of calculating this volume like that. Sa may volume, kinesia 3.97. Ang B is as already corrected, 2.434. Kinesia 2 meters. So sa may volume ana? The volume is area of the triangle, 1/2 the base. So 2.434. Multiply it by the height, 3.97. Multiply it by the length. Multiply it by the unit weight. So this is the result. Okay. Please check your answer if you got it correctly, or those who were not able to get it correctly. I would like to entertain questions, clarifications. Questions, clarifications, please. Okay. Mutana ta na abay clarification si Gomez. Aidan Troy Gomez.
Sir, can you repeat, Google sir, ngano volume ang gigamit sir?
Ang volume nga gigamit kanang imaginary volume sa liquid above the cover. Kini siya nga volume. Muna gusto nimo i-clarify.
Yes sir, nag-process pa ko.
Okay, question from Ruiz. Ariel, Ken Ruiz. Ruiz, any question, clarification? Nandra? How about Tigpos, Tipgos? Manuel? Tipgos? May nindot na may mga questions bawa sa answer. Saray pa na na, way nasabtan ta. Mo ni Kuyaw. Yes, Rona, questions. Rona? If pressure sa bottom, ang pressure sa bottom, in this particular case, dili siya uniformly distributed. Mas dako man og pressure diri nga side, no? Kay ang pressure nakadepende man na sa kanang erase, no? So kung ari ka sa bottom, ang pressure diri has something to do with this height. Ang pressure diri has something to do with this height. So if you're interested of the total force acting at the bottom, then equal na. So if you consider this diagram here, pressure at the bottom, it's either you can break that into uniform pressure o in triangular pressure distribution. Okay, so sa triangular pressure distribution, ang ganahan ta mo calculate sa force. Okay, triangular pressure distribution, average pressure, 0 dire, big value there, that's average pressure. Okay. Now, once you have the average pressure, multiply it by this area. And what you get is a force. And of course, the point of application, kay triangular pressure distribution man, dire, 1/3 from here. Yeah, sa kining apart, uniform pressure distribution, it is equal to this pressure, equal in so the average pressure is just the uniform pressure. Multiply it by the area in which the pressure is acting. So that's another way of calculating the forces. Since there are two forces involved, you can sum up the two forces. That gives you the total force at the bottom. Okay, Now, pwede sana nimo i-compare kini nga volume. Yeah, multiply it by volume, multiply it by the unit weight. That should tally. Okay, I hope that clarifies.
Ay, sir. Wala ako nag-feedback, sir.
Aha.
Wala ray feedback akong mic, sir.
Wala ra, okay ra.
Kuan, sir ba? If kana, sir, di ba, sir, ang katong first approach is naiduha ka resultant, sir, gikan sa triangular nga pressure and sa rectangular, sir, tas i-multiply nimo sa area sa base.
Yes.
So, from that, sir, it's naman kay duha ka resultant na force, i-add lang nimo sila, sir. Tas it should
Duha na ka
be
forces. Duha ka forces. Force due to the triangular pressure distribution. Yeah, force due to the rectangular pressure distribution. I-add na
Tapos-
nimong duha.
tapos mag-matter lang ilang placement, sir, when i-find na ang center of pressure nga location, sir ba?
Ang center of pressure dire, you can just apply Varignon's theorem. Varignon's theorem states that the moment of the resultant force, unknown man na. Diba? Unknown man na, si X bar. Kini known man eh. Naraman na sa center. Kini known man sab ni.
Yes, sir.
So, ma-determine imong X. Kung mo-apply kag Varignon's theorem.
Yes, sir. Pero ayaw rin na siya i-use pali, sir, when mag-ask na good for the location of the force acting sa bottom, sir, no?
Yes.
Okay, thank you, sir.
Any other question or clarification? Okay, yes, Gomez. Aidan.
Sir, sakto ba ako pagkasabot sir na ang left side ug bottom side mo ay mag-experience varying na hydrostatic force sir? Pero ang cover sir kay murag
Hasta ang
uniform
cover.
ra.
Ang
Ay,
cover
varying
also
po
will
ang cover.
experience varying.
Sige sir.
Kini ang pressure diri nga side sa cover dependent ini nga height. But because the liquid that we're talking about is imaginary, so ang pressure diri is going up. At that pressure is equal to gamma, multiply it by the Z. While ang pressure diri is zero. So triangular pressure distribution siya. Okay? So kung mo-calculate ka sa force acting due to the triangular pressure distribution, mo nga nagyapon ka 1/2 of the maximum pressure, which is gamma Z plus 0. Multiply it by the area. Ang area ana is equal to B times 2. Gets na to? So,
Yes,
ma-cancel out kani. So, kung yung ka gamma times Z times B, parehara na sa force na na-calculate na to earlier. Ano yung force sa cover? Ito ba? Palihog lang kong verify. Parehara, di ba? Any other question or clarification? None? Okay, so if that's the case, that's it for today. By the way, is Neil around? By the way, this has something to do with the activity sa 20 or sa SECON. Neil, are you there? By the way, kinsa man ninyo ang naka-register na sa SECON? I think na-communicate ninyo si Ma'am Kat. Yes, okay. Good. Yes, Erjan. Okay, register na. Now, the dean actually required all third year, pero the third year will be involved also in another major activity, that is the reverse scan. So, when she knows that the third year are involved sa reverse scan, she requested the department to encourage the fourth year instead of third year. So sa CA, fourth year niya, ang CHA, murag fourth year sab ang gikuan kay pareha man ta sa CHA, 4.5 pamanta, no? While the other disciplines, kay tag 4 years raman sila, so third year ang gi-require na mo attend sa second. Okay. So Neil, okay na Neil. What about the
Hello, yes.
contestants, Neil? Na-finalize na to katong sa Skills Olympic?
Sir, na quick question on ta ato sir kay sa Google form that you sent sir, it says na registration is open to all civil engineering students first year to third year.
Asa man katong sa Skills Olympic?
Yes sir, katong Google form.
Yes, the Google form is murag open siya. But ang sa contestants, kinahanglan raman tag 5 members, right?
Yes sir, so dili ra ni i-mind ang first year to third year nga qualification sa Google form sir.
Yeah, but ang akong open siya from first year to fourth year. But kita man ang mo decide sa contestants actually kung asa nga year level ta mo kuha.
Sige sir. So aside from
So,
that sir, wala ra
That is fourth year or third year.
okay, sige sir. So aside from that sir, wala ra daw line qualification sir for this contest.
Wala siya, no? Because this is a contest, meaning when you talk of contest, mopili gyud ta nga katong makasugakon sa contest.
Sige
Mura
sir.
na itong requirements and tanawa dito on sa mga requirements nila. That's why I will ask you to coordinate with Sir Bardon.
Sige sir. Okay.
Okay.
Nag-ask ko sir because so far na pay usa sir nga ni show interest to join from my batch. I don't know about the third year sir, pero for the fourth year batch kay so far na ay usa.
Sa previous batch, murag 5 ra sa to sila, but ang nag-choose adto si Engineer Bardon.
Okay
So,
sir.
palihog lang ko coordinate niya once ma-finalize na ang list, please tell me kay I have to communicate it to the organizer.
Sige sir. Sige, will do sir. Thank you sir.
Okay, so I guess that's it for today. Bye-bye for now.
Thank you, sir. Bye, sir.
Thank you,
Sige
sir.
sir.
Yes, sir.
They not ask sir if when you'll be uploading now the lecture recording sir.
Ang video recording, normally din ako mag-upload sa mga video recording because I want you to really also listen to the discussion atas atong klase.
Sige sir.
Pinakay ko
Thank you,
mo post anang video recording, Neil.
Sige sir. Thank you sir.
Okay.